that. And our guest speaker tonight is Professor Rudi Lindner, who has spoken to us so many times I've lost track, actually, in a wide range of topics, anywhere between why men go mad at a certain South African observatory to the history of UFOs and just about everything in between. And tonight, we're honored to have him here to talk about the Michigan-California axis in astronomy. And he said I didn't really have to do an intro, but I had to do a little bit. So with that, I will turn it over to Professor Rudi Lindner.
Just call me Rudi. Just call me Rudi. I think I first attended a meeting of the Lowbrows in maybe 1981. It was a small select group. And I'm very happy that the group has grown and prospered over the years. I believe the last time I spoke with you was a July meeting at EMU, which happened to be on my birthday. So you were very kind enough to bring pizza and cupcakes and not to throw the pizza or the cupcakes. So I remain grateful for that. I'm going to talk about what people would call the Michigan-California axis in astronomy, which is really about the connections between astronomy in Michigan and astronomy in California, beginning in the 1870s or 1880s. That's the title. I'm really just going to show you some pictures I like, and you can decide their relevance.
Last 2 meetings, so you're all right.
So, and if anyone has any questions, don't hesitate to interrupt or send me. I already have something on the chat. The sound is still quite low. Speaker needs to keep the microphone close or we get broken audio.
We just show me this happen.
I will do my best to hold this up. And, you know, the next thing would be to put it in one of my nostrils. And that would not go over well on
We did something
on YouTube. Now, the biggest event that's occurred since I last spoke to you, other than my continued maturation, is that I formally retired from the university, although I still do some teaching, which means that I am what is called in the medical field a recovering academic. So I just have to warn you that there may come a time when this young man's boredom may appear. I'm sure that you know this old painting of the Detroit Observatory as it existed in the very early years of its use. And you see the main entrance from the north, and to the right you see what was a classroom, and to the left you see one of the slits for the transit telescope. This is what the observatory looked like in a postcard from the 1930s. Here we are looking from what is now a dormitory, and you see in front of you the residence of the director of the observatory. Then you see the dome of the old Fitz telescope. And in the back, you see the building that was erected between 1905 and 1911, which housed a 37-inch reflecting telescope that was used entirely for spectroscopic observations. Now, the classic instruments of the Detroit Observatory up until 1911 were the Fitz refracting telescope, here seen with a tube that was added in 1906. And on the right side, you see the meridian circle, the transit instrument. In other words, the Detroit Observatory from the 1850s until 1911 was dedicated to what we call the old astronomy, the astronomy of precision. That is to say, the astronomy whose major goal was using the laws of Newton to be able to predict the motions and the positions of celestial bodies. And that is fundamentally what the Detroit Observatory did for the first half century of its existence. It is, however, true that during that time, and indeed until the 1930s, anyone who took a degree in engineering from the University of Michigan had to have at least one astronomy course and had to know the ropes, so to speak, about the sky. And a number of those people who studied engineering actually ended up going into astronomy. And for certainly until about 1905, 1915 or so, University of Michigan was producing a fair number of degrees in astronomy. The great memorial to that half century is this book, The Elements of Practical Astronomy, published originally locally here and then published nationally by the Macmillan Company in New York City, by one of those engineer astronomers, Wallace Campbell. We'll get back to him later. And this book is essentially a book for people who are interested in determining the position of celestial objects or who are using astronomical instruments for, some purposes here on Earth. What are the institutions in California with which I'll be dealing? The first is the Lick Observatory, east of San Jose, California. This is needless to say, done with a telephoto lens. It's one of those things that briefly makes you believe those stories about the moon, the full moon tonight is bigger than it will ever be, et cetera, et cetera, et cetera, and the rest of that. Lick Observatory, founded in the 1880s, and a number of the Lick staff came from Michigan or came to Michigan. Lick Observatory had two main instruments. I'll get to those in a minute. The other California institution is the Mount Wilson Observatory, which was the first American observatory that did not have a transit circle and where they didn't give a hoot about the position or the movements of the planets or stars. Their interest was in what we call astrophysics. What is the makeup of the universe and what is the evolution and how does that evolution occur among the stars and other objects? So at Lick, there were two main instruments, just as at Michigan. There was a big refracting telescope. There was also a small refracting telescope. Optics made by Alvin Clark, mounting done by this Cleveland firm of Warner and Swasey. A magnificent example of the art of engineering in the United States. James Lick is buried inside the mounting of this telescope. The suggestion was made to him that he be cremated, and he said in response, "Sir, I intend to rot like a gentleman."
Oh.
And as far as we know, he is doing so. On the right-hand side was a transit instrument like that of the Detroit Observatory, which was in use until about 1920, when there was a feeling that it was no longer needed, and it was removed from its building, and it was thrown down the side of the mountain. You may see its remains today, but it is not advised that you attempt to examine them, since it now houses a very jealous family of rattlesnakes. The Lick Observatory turned in the direction of astrophysics in the person of its second director, James Keeler, who had been trained as a chemist and became very much interested in astrophysics. And he was the director of the Lick Observatory from 1898 to 1900. And how he turned the place around is that the Lick Observatory had been given a 36-inch reflecting telescope that belonged to an English amateur, Edward Crossley. Telescope still exists and is still in use, the Crossley reflector. And you see a schematic diagram of it on the right-hand side. When the Crossley reflector arrived at Lick, people found it extremely hard to use. And if you take a close look, you can see sort of from the mounting that it is not the strongest or sturdiest thing available. Now, one thing you can try to do from where you are seated, or if you're at home and are viewing this through a computer screen, is if you let your eyes get lazy and cross them, you should be able to see in the center the stereo view of this instrument. On the screen is too big, I can't do it, but
Yeah.
at home I could do it. The Crossley reflector was universally hated by the astronomers at Lick Observatory because it simply would not operate the way they wanted it to. Keeler decided something, it should work. And so Keeler discovered upon examination that the instrument had been set up as if the Lick Observatory was located at the same latitude as Crossley's observatory, which was 7 degrees of latitude further north. It was not entirely unexpected, therefore, that the Crossley reflector as it then existed would never follow the stars. Keeler put in a shim, and then it worked. And with it, he began to take photographs. Later on, they changed the mounting. This is a mounting from 1905, which is still in use. I have it on reasonable authority that the model for this mounting was 2 cement mixers having sex.
That's the best way to.
Even in the new mounting, it still is ornery. When I first saw it in the 1950s, the gentleman in charge of it went up to the mounting and kicked it, and then invited me to give it a good kick too, so that it might improve things. Keeler began to take photographs and began to take photographs of nebulae. And so here is a plate that he took on, I think this is Messier 101. You will notice that the exposure was 4 hours. I believe that any of you could equal that exposure in about 15 minutes. And then Keeler did something very interesting. Keeler began not only looking at the image of this edge on spiral, but he began examining the rest of the plate. And what he discovered was that there were lots and lots of other nebulae, spirals, ellipticals, and others. And he suddenly realized that the spiral nebulae are not rarities, but they are very common, and that therefore they needed to be understood. Unfortunately, Keeler died before he was able to pass this any further. Here, by the way, is an amateur photograph of this. It's known as the Silver Sliver, and it's conceivable that you have at one time or another viewed it. Now, I mentioned the Crossley because when the University of Michigan decided to build a big reflector, they decided to build an instrument the same size as the Crossley and with the same kind of mounting. So this is the mounting of the telescope with its spectrograph as it was in 1911. And it worked so well that other people began to ask for the plans and use the same idea. So this is the Dominion Astrophysical Observatory's telescope, which was modeled. The mount was modeled on the Michigan 37-inch telescope, which was modeled on this English yoke axis of the Crossley reflector. Another major instrument was the 69-inch reflecting telescope at the Perkins Observatory in Ohio. Again, modeled on the Detroit Observatory reflector, ultimately on the Crossley reflector. So one of the ways in which there is a back and forth between California and Michigan is in the design of telescopes. Here is one of the famous Russell Porter cutaway drawings of the 200-inch telescope at Palomar Mountain. And you will see that it has this interesting, at the northern end, this sort of horseshoe yoke design. And here one of the working drawings for the 98-inch telescope at Michigan, which was never built. And the working drawing shows a mounting that is exactly the same as the mounting of the Palomar telescope. You know, in some ways it's different. The modeling is it's a little retrograde in some ways, especially with respect to the tube. But this notion of having a polar yoke was taken from Palomar. So there's borrowing back and forth in the way of instrumentation. This man, John Shaberly, was born in Germany, but came when he was a baby to Ann Arbor, grew up in Ann Arbor, studied engineering and mathematics at the university, studied astronomy, became an instructor in astronomy, and is one of the first staff members of the Lick Observatory. He was brought out there. Shaberly's an interesting man. He actually made reflecting telescopes. And one of the mirrors that he made, an 18-inch mirror, part of it still exists and was in use in the Department of Physics at Michigan for some time. Shaberly's telescopes were interesting because he liked to have short focus reflectors, which of course it's very hard to fabricate a good paraboloid, but apparently he was able to do it. At the Lick Observatory, Shaberly interested himself in a number of things. One of them was the observation of the sun. And Shaberly designed what is this 40-foot long camera for the observation of the sun at a solar eclipse. And the Shaberly camera was used for 40 years and went to every single solar eclipse, no matter where it was in the world, from the late 1880s until about 1930. The Shaberly camera is interesting because the camera does not move. What moves and tracks the sun is the plate holder at the bottom of the instrument. And Shaberly designed this, and it held plates that were 11 by 18 inches, glass plates. And here is, one of his. So this was taken in India. And for many years, the Lick Observatory had by far the best collection of solar eclipse plates. And there is a crater on Mars on the left and one on the moon on the right, named after Shaberly. Now, when James Keeler was made director at Lick, Shaberly resigned and returned to Ann Arbor, where he lived until 1924, 1926, as a private astronomer. He had no formal affiliation with the university, but he always showed up for observatory solar events. Astronomy events. And he's buried here, and you see John Martin Shaberly, 1853-1924, astronomer, scientist. He was very proud of what he did. He devised an interesting theory of the corona, a mechanical theory which doesn't work, but it made sense given what people knew in the 1880s and 1890s. So Shaberly is an example of somebody who came from Ann Arbor and had a major impact at one of the California mountaintop observatories. Our next figure is Wallace Campbell, an Ohio farm boy who came to Michigan, studied engineering, got interested in astronomy, got a degree in astronomy, and actually taught astronomy at Michigan. He was ultimately hired to go out to the Lick Observatory, where he had a brilliant career. In fact, he went from being an observer at the observatory to being president of the University of California to being head of the National Academy of Sciences. Here he is in 1931. Albert Einstein is spending part of a year at Caltech. And on the bench, you see the Nobel laureate Robert Millikan, Einstein, the Nobel laureate Albert Michelson, and then Wallace Campbell. Notice anybody else?
Or what year was this?
This is 1931.
I know, I,
Pardon me? No. But in the back is Edwin Hubble.
the tall,
Tall man in the back.
yeah. Makes sense.
Hubble never in group photographs comes to the front. He always is in the back, where he still towers over everybody. So here is Wallace Campbell as a young man at the business end of the Lick telescope with a visual spectroscope. He was very much interested in the spectroscopy of new stars, of novas. He was also interested in using the spectroscope to determine the velocities of stars. That was his major program. And he designed a large photographic spectroscope, a spectrograph, for the Lick instrument, which he, and after he became director of the observatory, the people who worked under him did very important work with. He also wanted to work in the Southern Hemisphere. So we got a wealthy San Francisco donor to buy a 36-inch reflecting telescope, which they set up in South America and used for the same type of spectroscopic program that Campbell had been using in the North. It's a very interesting idea to, have a program and then say, okay, we need to have this as full coverage as possible. And so get the funds and arrange to have a Southern station, which they did for a number of years. One of Campbell's discoveries, which is fascinating, was that here we have just a random photograph that shows blue and yellow and reddish stars, the stars of different spectral type. Remember, the sequence from blue to red is spectral sequences OBAFG KMRNS. You know the acronym, you know the way that goes?
First part.
Oh, be a fine girl, kiss me right now. Either sweet or smack when she hits the guy. The more modern one is, oh, big and furious gorilla, kill my roommate next Saturday. Campbell discovered that stars in the OBA class had very low velocities. Stars, the reddish stars, KM and et cetera, had very high velocities. This was known as the Campbell Effect. And nobody was able to explain it until the 1950s, when it turned out to be intimately involved with stellar populations and the dynamics of our galaxy. Campbell ran a data factory, and he was very careful about getting as much data as he could and then turning to the theorists and asking them what they made of it. He was an extremely important West Coast astronomer, which means he was an extremely important astronomer. And he is one of the Michigan exports to California. Here, the first meeting of the American Astronomical Society held in Berkeley in 1914. You see in the center is Campbell. To his immediate right, from your perspective, is George Ellery Hale. Towards the back on the left, there's a young man, 1, 2, 3, 4, 5, 6. From the left end, that's Harlow Shapley. And in the very front, seated on the grass, are Campbell's favorite graduate students. And in front is his really favorite, Heber Curtis, native of Muskegon, Michigan. We'll come back to Heber Curtis. Campbell was also, he went on these solar expeditions, took the Shaberly camera along. Here he is in Australia in 1922. When Campbell's in the center with the bow tie, 2 people to his right is Heber Curtis, who at that point was at the Allegheny Observatory in Pittsburgh. And in 1922, Campbell was able to take photographs that cemented the observational, how should I put it? The observational proof of one of the predictions of Einstein's general theory of relativity. A rough contemporary at Michigan of Wallace Campbell was William J. Hussey, lived on number 5 Packard Road in Ann Arbor. And Hussey was also from Ohio, got a degree in engineering, got interested in astronomy. became an instructor of astronomy at Michigan, and then was hired at the Lick Observatory. Another person who was a contemporary of Hussey was the woman who became his wife, Ethel Fountain Hussey. If you know the building, the Michigan League, that is her legacy. And the Hussey room in that building is in her memory. Ethel Fountain Hussey was a classmate of Hussey's, of W.J. Hussey. When he showed up at the Lick Observatory, she showed up, her family moved to California. I have looked at their correspondence of Ethel Fountain Hussey, and she writes, it's in the Bentley, Bill Hussey has been bothering me again. I just don't want to see him. And this goes on for 6 months, and then there is a 1-month hiatus in the correspondence, and then they are engaged. Go figure. W.J. Hussey used the 12-inch Clark refractor at Lick Observatory to observe double stars. He got fascinated by double star discovery and observation, and that was his career. That was where he made his name. Because of his eagle eyesight, the Carnegie Foundation hired him to examine possible sites for what became the Mount Wilson Observatory. And here is the kind of observing shack that was set up at Mount Wilson. And it is Hussey who recommended the Mount Wilson site to the Carnegie trustees. 2 years later, the Regents invited him to come back and finally make something of the Detroit Observatory, which was, at that point, was on pretty hard days. I think the thing that impressed me the most is I looked at an inventory of the observatory, and next to each other in the inventory were their lawnmower and their spectroscope. The lawnmower was worth more than the spectroscope. When Hussey came back, he had 3 things on his mind. One, a big reflecting telescope, and I showed you the picture of the 37-inch telescope. The second was a big refractor in the southern hemisphere to discover double stars. And the third was a solar telescope like the tower telescopes at Mount Wilson. And you know, he got his way. The Regents provided him with the money to get the 37-inch telescope. He went to the southern hemisphere to look for appropriate sites. In fact, for a couple of years, he was the director of the La Plata Observatory in Argentina, which had a rather old French refractor, which he didn't like. He wasn't able to make any, the optics weren't really very good. So he got his friend Robert Lamont, who had also wanted to marry Ethel Fountain Hussey. And Lamont gave him the money for what became the Lamont Hussey Observatory in Bloemfontein, South Africa, which is now being really refurbished. There's a really good group of amateurs down there. And he got his solar telescope. This is the McMath-Hulbert Observatory, which was founded by a group of amateurs who befriended Hussey, and he was friends of them. And they began a nice close association, which ended up with this really interesting observatory. Notice that this cutaway drawing on the right is also due to Russell Porter. If you were setting up a nice observatory and you wanted to have a special cachet, you got Russell Porter to do the drawings. I'm sorry. I'm betraying my age. Do you all know who Russell Porter was? Okay. Russell Porter is the founder of amateur telescope making in the United States. He helped design the Palomar telescope. And he's the guy who started, for instance, Stellafane at Springfield, Vermont. He's responsible for that. And he's responsible for, there's this book that I don't think anybody reads anymore, Amateur Telescope Making in 3 volumes. It's a great book. It will tell you just how to build a perfect telescope in 1926. But it's fascinating. It's fascinating. So Porter was a marvelous engineer and designer. Anyhow, among the people who now were recruited to Ann Arbor, so Ralph Hamilton Curtis was recruited from Lick. He got his PhD from Lick and was recruited to run the spectroscopic program in Ann Arbor. And Curtis began a long tradition of observation of stars which had variable stars that had peculiar spectrum, stars that are spectral class B with a lowercase e, which means that they have an emission lines in their spectrum. So you can see here, if a star has an atmosphere that surrounds it at a distance, if you look at, you will see, if you look at the spectral, you will see, you know, the normal absorption line in the center, but you'll see from that part of the atmosphere that's going away and the part of atmosphere that's coming toward us, you'll see these 2 wings. And Michigan was a center for the study of these peculiar stars with peculiar spectra for many years. And Curtis came from Lick for that purpose. Another Californian who ended up at Michigan for 4 or 5 years was Paul W. Merrill. Merrill was hired also to work with the big reflector. But at the time that Merrill came, something very interesting happened. I'm sorry, I don't have a slide to show you. But are you aware that as you ride on Huron Avenue going west, and then it turns and angles south through the university, that you pass the big heating plant? Well, the gases from the heating plant go directly over the Detroit Observatory. And Merrill was in charge of a public viewing one evening, and he said, "I give up. I couldn't even center the image of the moon. It was shaking so much." So at the end of World War I, Merrill went back to California, went to Mount Wilson Observatory, where he had a long and very interesting career working on variable stars, just as had Ralph Hamilton Curtis. Yes, I'm glad the McMath-Hulbert Observatory still exists. I haven't been there in a while. There's a group of amateurs. It's a wonderful institution.
Actually, I have a bit of a sad update of the society that was there.
Yeah.
I think they were kicked out of that space.
Oh, really?
The place still, but the society folded into the Warren Astronomical Society.
I see.
I don't know what's to become of that site.
The only thing that they need.
This is Jim Chetowski. I'm a member of the McMath-Hulbert Astronomical Society. We still exist, and we have been evicted from the property, but we're still active, and we're trying to achieve national registration for the observatory itself. There's still some activity going on.
Are we trying to get back to the observatory, Jim? Or are we kind of, or is the society letting it go?
And Jim, I don't hear my question. No, I can ask him later.
Okay. When I was there, the one thing they needed was they needed a Leo birefringent, can't think of it now, filter. And that would set the large solar instrument in use again. I'm sorry to hear that. I would like to know about that. I think it does, it was for a time the finest solar observatory in the United States. And they designed there a series of vacuum instruments that gave them images that were better than the images from the Mount Wilson Tower telescopes. What happened was that they did not have people there who could work with the theory of what they were seeing. But it certainly deserves to be on the National Register, and I'm sorry that they're no longer there. I will tell you one other thing about Paul Merrill. Paul Merrill was a rock-ribbed conservative Republican, and he would arrange around election time to schedule time so that the Democrats who worked at Mount Wilson would have to be on the mountain observing and could not vote in Pasadena. So there you go. But he was a remarkable astronomer, and he was, again, had been a Michigan man. Now, you know Hazel Losh? Hazel Losh was, she had a great reputation as being both a good and a bad astronomy instructor. The legend about her was that she gave A's to athletes, B's for boys, C's for co-eds. And she would say, and D's for dummies who believe that. Hazel Losh got a PhD from the University of Michigan for a very, very fine, I don't know if I have a picture of it. Yeah, very, very fine study of the emission star Zeta Tauri. And she went to Mount Wilson, worked there for a while, didn't like it because they were not allowing women to observe. And she was relegated to doing mathematical work there. She was considered for a position at the Case Western Reserve Observatory. But the director said, I cannot hire you because we need this telescope does not work unless there are at least two people there to work it. And I will not allow a woman and a man to spend the night alone in the dark dome. So she came back to Michigan and had a long career, mostly in teaching. But graduate students would go and sneak into the library, well, they didn't have to sneak into the library, they would go in the library and sneak a look at her dissertation. It's a first-class astrophysical dissertation. And she is one of those people who, I think it can be said that her gender prevented her from having the opportunities for observation and for publication that, would have been hers a generation later. So she was somebody who was hired away from Michigan to California. She had expectations. Once she got out there, it didn't quite work out. And so she came back and had a long career at Michigan. Another person was Arthur Wise, who got his degree at Michigan, went out to California, worked at the Lick Observatory, had the beginning of a brilliant career. He was interested in gaseous nebulae. He was interested in stars in the last stages of their evolution. He had a remarkable gift for astrophysical theory. When World War II came, he was immediately drafted. Before he could be put in the scientific division, they had him out with observation balloons And tragically, his balloon crashed and he died. But everybody had expected him to be the next director of the Lick Observatory. And his work is still cited. His niece is, by the way, a Michigan graduate. And then we come to the sage of Saginaw, Heber Doust Curtis. Now, astronomy is one of these fields which in the early years of the 20th century, you got people with funny names. How many people do you know named Harlow? Right? How many people do you know named Heber? Now, Heber is actually a good Mormon name. So in Utah, you'll find them, but on the whole, you don't. Heber Curtis came from Saginaw, graduated from Michigan in the class of 1893 with a degree in classics. Never set foot inside the observatory. Went out to teach classics in California. The place he taught at had a small telescope. He did some observations, got really interested, made a connection at Lick, got his PhD degree, and he was the person who was in charge of photography with the Crossley telescope, which is where he is here. And with the Crossley telescope, he completed the work that Keeler had begun. For example, he discovered that there were novas in what we would call supernovas in spiral nebula, which caused him and a few other things to become the champion of the notion that the spirals are separate galaxies. And in what is known as the Great Debate on the Scale of the Universe in 1920, he argued against Harlow Shapley. Shapley argued that the spirals are within our galaxy and our galaxy is huge. Curtis argued that our galaxy is small and the spirals are other galaxies. They were both right. Our galaxy is much larger than people had thought, and the spirals are other galaxies. Curtis came back to Michigan as director of the program in 1930 and served until his death in 1942. Curtis was a very, very important astronomer because for a time, he was the sole champion of the notion that the spiral nebulae are separate galaxies. He was a great instrumentalist. He helped arrange for Michigan to have to get the mirror blank for a 98-inch telescope. Now, ultimately, the crash occurred in the Depression, and they were unable to build this telescope. And Curtis said later, maybe it was all for the best, because why would you want a 98-inch telescope in this climate? And so what ultimately happened was the mirror was given to the royal astronomer in Great Britain, who set up the 98-inch Isaac Newton telescope on the outskirts of London, where it had an even worse career than it would have had in Washtenaw County. Yeah, it's now in the Canary Islands. Yes. Another Californian who came to Michigan from Lick was Lawrence Aller, who was probably the most accomplished astrophysicist in terms of spectroscopy that Michigan had. He made a name for Michigan because of this book, Atoms, Stars, and Nebulae. If you wanted to learn about astrophysics in the 1940s and 1950s, and you were a high school student or a college student, this was the book. Aller did a second and a third edition of it. It's still in paperback. The book has been in print since 1942, and it's still relevant. And you can't say that for many books on astrophysics that they've had, an 80-year career. Aller also was known at Michigan for his quick temper. He went to see the vice president of the University of Michigan at one point in the 1960s to complain that the university was putting more money into an art museum than it was into its astronomy department. And Aller said, you know, you really, you give the money that you want to the art museum, but you really should not let the astronomy department die on the vine. We have lots of projects that we can do. The vice president said, no. And Aller said, well, maybe I'll leave. And he said, fine, you go away and we'll replace you. Aller left and he was not replaced. And there began a long period of uncertainty in the department. There's a few more things in the chat. How long does it take to make a 37-inch reflecting telescope? Just a minute. So the 37-inch reflector was built by the Brashear firm in Pittsburgh. It took about 6 months to fabricate the mirror. The mounting was largely fabricated here in Ann Arbor, and it took most of a year to do it. The 37-inch disc, which is made of plate glass, you know, Coke bottle glass, it's still on campus. I'm not quite certain where it is, but it's still on campus. I've seen it. And as you may know, that plate glass responds to temperature changes in a way that Pyrex fused quartz, et cetera, don't. So what the 37-inch mirror now is, and I just need you to be aware and be proud of it, it is the largest thermometer in the United States. Don't say that I don't tell you anything of interest. Here is the American Astronomical Society meeting in Ann Arbor. On the far left in front is Heber Curtis. This is 1937. Now from the front and the right, you have a woman and child. 1, 2, 3, 4. The fifth person, he's relatively short, is Dean McLaughlin, who the Lick Observatory tried to hire away from Michigan, but he refused to go. But McLaughlin had a brilliant idea. Michigan had a 98-inch mirror blank. Lick Observatory didn't have a really big telescope. Why don't we give them the blank? They can build a 98-inch telescope at the Lick Observatory. The seeing there is excellent. The viewing conditions of the Lick Observatory are superb, even though San Jose is, you can see Half Dome in Yosemite from the Lick Observatory. It's 100 miles away. Yes, you can. It's tiny, but you know, if you have a spyglass, you can see it. McLaughlin suggested that this take place. The regents, however, refused to let the mirror go out of the state in the early 1940s. So it would have been an interesting thing if they'd done that. Another product from California who ended up at Michigan was Robley Williams, hired to work on instrumentation. Very interesting man, Williams, came to Ann Arbor. He was one of the first people to use the illuminization process on telescope mirrors. And he was a master of that process during a time when it was very, very difficult to do. And he worked on astrophysical topics at Michigan. In the early 1940s, the University of Michigan had an electron microscope. And Williams talked with the people in the medical field who were using it and said, look, could I maybe use this to examine the shape of like an astronomical mirror that we use? And they said, sure. And he did some work with that, but he got really interested in the work that they were doing. So here is an early electron microscope photograph of a tobacco virus. And sure enough, Robley Williams decided that he was going to become a virologist. And so he ultimately left the Department of Astronomy at Michigan, came back to the University of California at Berkeley, where he was one of the path breakers in the field of the study of viruses. You know, this is Michigan-California axis. It's pressing it a little bit, but what the heck? The last person, and there are others, is Carl Henais, astronomer. He was the first astronomer who became an astronaut. And Henais worked at Michigan, but also had an appointment at Mount Wilson. On the right, you see a photograph of him at the Lamont Hussey Observatory in South Africa, where he was photographing hydrogen objects in the Milky Way, gaseous nebulosities, things like that. And he was a pioneer in helping the study of galactic structure. He then came back to Michigan, got a job at Northwestern, and then became an astronaut. And here is one of his discoveries, one of these Henais objects. It's a super bubble, which is when a star, a big star, a massive star is towards the end of its life and some of its atmosphere blows away. And the kind of the pressure of the, what we might call solar wind, creates these large bubble-shaped objects. And that was something that he did. Well, I hope I've helped you to understand that I mean, after all, we don't have the clear skies of Arizona. We don't have the big telescopes of California. But it's interesting that even when the program was a program that was fundamentally positional, that Michigan turned out people who would go to a place like California and would blossom, would become leaders in the field of astrophysics. And then people from California might come and study at Michigan and work at Michigan and further fertilize the field. And that's what I mean by the Michigan-California axis in astronomy. Do you have any questions or?
Question. We had.
Norbert has a couple of questions, if I may, for Rudi.
Yes.
One, your stereoscope image some frames back, do you happen to have a little stereo viewer for that? Because we have a couple of pairs of them up at Scherzer in an archive room, the ornate wood with the lenses and so forth, and exactly those things, which must have been fad back then.
Yeah, no, I just use the, the thing of easing my eyes. There are a number on the web of stereoscopic views of astronomical instruments. Let me think about this. I may send you an email. Thank you. Thank you.
I appreciate that because I could employ those with the their back in the day stereoscope viewers. The other question I had was, what do you make of the new Detroit Observatory renovation? Have you worked with Gary Krenz on any of that? Your historic facts are absolutely fascinating, and I love the Peyton Place touch.
Well,
Adrian?
I'd like to give you an answer. I think that architecturally, it is hopelessly out of place in preserving the visual impact. I understand why they've done what they've done. And also, the University of Michigan is not known for great architecture. You know, the Burton Tower is far too short, other things.
States, I can tell you that. Well,
Fair enough. Fair enough.
But
I think that, you know, there's this other aspect of it that I'm not entirely happy about it. It's now no longer called the Detroit Observatory.
yeah,
It's called the, you know, the so-and-so and so-and-so Detroit Observatory. Well, if they gave the money, I understand that.
mm,
But I'm not entirely happy with it. I also
appreciate your candor on that. The U of M hospital's building that massive building right across the street from it too. I don't know if you're aware of that.
yes, there is also there are two people alive who helped save that building from destruction in 1974. They are Peg and Nick Stenick.
oh, yeah.
Mm,
Had they and a group of others not gotten on their hind legs and screamed bloody murder, you know, wouldn't be there. And I'm not certain that they have received, especially in the celebration recently, the recognition that they deserved. And I feel a little bit the same way. Norbert, we should talk about this privately.
yeah, okay. I appreciate your candor and it's, these things are good to know
Yeah.
because the
it has
history
been-
is important.
Yeah, it has been said that I have the tact of a thermonuclear device.
Okay, fair enough.
And-
Thank
and
you.
the-
Thank you, Rudy.
Yeah, the older I get, I say, you know, what the heck? You know, what's going to happen to me? They'll haul me before Judge Judy. You know, so that's but I think, look, the crucial thing is that even though the new structure is, I think, not visually enticing, and I'm not certain how many students will go up to that corner of the campus. It may be end up being used more by the medical school people. But, you know, the instruments have been saved. The one thing that needs to be done is to have, and I asked for this in 1990, someone come in and analyze the figure of the Fitz lens. It is the largest Fitz lens that exists today that has not been refigured. It is the largest existing lens whose fabrication was largely the work of women. Final figuring was done by Fitz. All of the other historic refractors in the United States, I have a file of them. Someone has gone and analyzed the color curve, what it was best corrected for, where it best served. We don't have that for this telescope. And Fitz, you know, Fitz worked before the kind of tests that we now have available. And it would be really good to know that. You know, what is it? Edward Emerson Barnard, the great Barnard of Yerkes Observatory, sometimes he would find a planetary nebula by a suspicious object. He would focus the 40-inch refractor, whose focus for green and focus for yellow were almost an inch apart. And since planetary nebula usually nebulae exist, you know, they're only particular wavelengths. If you saw it come into particular focus there, he was able to say things about it. Fascinating, absolutely fascinating work. I'm sorry.
No,
You sure?
I was just scratching.
Yeah, Rudi,
I have that impact on people. Yes,
Rudi, this is Jim Chudlowski.
hi.
I was the one who had the comment about the McMath-Hulbert Observatory, and
Yeah.
if you'd like an update on what's going on there, and that somebody at the meeting, I'm sure could give you my contact information. I'm a member of the Lowbrows, and and I'm involved with. We are trying to repurpose the observatory, and there's major effort going on different fronts. So. Love to talk with you about it.
Okay, thank you very much.
I'd love to talk with you about it too, Jim. I think I joined the Big Man Hubert Society some time back. And need to catch up with see where things are and renew my membership. We did put the McMath Hubert Observatory part of the Great Lake Association of Astronomy Clubs. I think we inducted it during the beginning phases of COVID in 2020 and said this would be an important society to have that of our organization.
You had a comment or a question tonight.
The comment was about the fate of one of the telescopes that was formerly a part of that observatory, and most lowbrows know where I'm going with it. It gives me pleasure to know that such a big part of the history of astronomy rests.
Yeah, that's the 24-inch.
That's 24 inch. And
Yeah.
having an opportunity to operate it on my own and almost watching it swing into the side of the wall and stopping it before it hit. Sorry, Charlie, I wasn't going to tell you I did that. Before it hit, yeah, I kept it intact.
You know, you should see me at a telescope. I'm like the great theoretical physicist Wolfgang Pauli. It was said he had an office in the physics department of the Federal Technical Institute in, I don't remember, Zurich. And it was said that as he walked down the hallway, lab instruments behind closed doors would break. And they had one place in Göttingen or someplace like that in the physics department where some instrument broke down completely one day. No explanation until somebody found out that Wolfgang Pauli had been on a train going to Berlin that had passed through Göttingen just at the moment when the instrument broke down. The 24-inch was used in the 50s by William Lindner for some really interesting work. I won't say pathbreak, but really important work on planetary nebulas. It's interesting. McLaughlin once wrote an article about the 37-inch telescope, and he said, every time the seeing in Ann Arbor gets worse, Kodak comes out with a faster emulsion so that we're barely able to keep up. Now, of course, you know, it's phenomenal what you can do with, I was just talking with Charlie about the latest issue, the July issue of Sky and Telescope. You open the front cover, and on the page, front cover inside, then the next is these photographs of M17, you know, and that's stunning, absolutely stunning.
Yeah, and we actually have a couple of astrophotographers that have produced work like that, and I have to know of have you heard of Doug Struble? Amateur.
I don't think so.
Struble. Who's gotten some of his work published. He's in the Plymouth. There's a Plymouth astrophotography group where gentlemen who've had APODs and have produced images.
Interesting.
For Sky and Telescope has picked up, and Astronomy magazine have picked up. And
well, I always enjoy seeing the photographs that you all put up. It's just interesting. And when I was teaching, I would talk to, I would talk with people about it. I would talk with students, and I would show them an image that was taken. Well, Barnard, poor Barnard used the Willard photographic lens, which came from a portrait photographer in San Francisco, f8.
Okay.
And he would, it was a 5-inch lens. He brought it up to brought it to Lick Observatory, put it on an equatorial mounting, and he would have these 6-hour exposures. And they made up his photographic atlas of the Milky Way, which is dazzling. The images are points. But, you know, in January at the Lick Observatory at 5,000 feet, it's not very toasty. And then you have these, these wonderful things that you can do nowadays. It's amazing. I'm sorry, yes.
Why do telescopes have to be so big?
Because what you really want to do is to gather as much light as you can. So if I have a 3-inch refracting telescope, which I have in a case back at home, which I really ought to open up one of these days. And I was taught the manual arts by Captain Hook. I once had an 8-inch Celestron Schmidt Cassegrainian telescope, and I tilted up, and the eyepiece fell through into the instrument, banging around, proceeding to ruin.
Yeah.
I called up Celestron, and they said, "How did you manage to do that?" I said, "I don't know." They said, "Send it back to us. But, there's not much that we can do." So I gave it to UPS. Mercifully, the UPS truck backed up over the telescope, smashing it to smithereens. And I was able to buy, a nice 3-inch refractor that I was able to use. So with a 3-inch diameter telescope, you can see stars of the 11th magnitude. But if you want to see stars or objects that are fainter, and especially extended faint objects like nebulosity, you need a larger aperture. So that's why. Now, it's fascinating that with new photographic techniques, there's a man in Denver, Edgar Everhart. He may no longer be alive, but many, many years ago when the Earth was young, he had some photographs in the sky on telescope where they had a photograph that he had taken and then a photograph that the Mount Wilson 100-inch telescope had taken.
Very similar.
Edgar was doing pretty darn well. So that is my simple-minded answer.
Yeah, the imaging.
You're taking image over
You're exposing over time.
then doesn't have to be the explanation is that
because similar to what Hubble does,
focuses
on
a particular
area in the sky, and it
But
does so for a long amount of time.
time, photons
Continue to
hit,
and then they get gathered
and
an image
is built
that way with
your eye.
You need as much light gathering
power as possible in order to see similar.
The eye is inefficient. And the camera now, especially digital cameras that use these, what we used to call CCDs and CMOS, they gather, yeah.
That's
Yeah. So that does, it's fantastic. I mean, it's impressive. I belong to the Stockton, California Astronomical Society, which I joined in 1953. I've told you before that nobody has been a member of that club longer than I have, and nobody has missed more meetings than I have. It is now 61 years since I attended a meeting. But their founder was a man who had a 12.5-inch telescope, and he took photographs of the great nebula in Andromeda, and he was very proud of them. And they became, there was a centerfold of them in Sky and Telescope, and, you know, taken hours after hours after hours. But nowadays, you know, it's you know, you can watch TV while it's happening. Yes, I'm sorry.
Photographic scientist for 7 years of my career, and what we believe was that it took 3 photons in order to activate a silver crystal in order to be developed. Now, of course, one crystal developing isn't enough to see it on screen, but that's how much you need in order to turn one into.
So starts with capture
Then you got 1 million crystals that can do that.
where the time then comes
But
in.
of course, that was back in the 80s, so I don't know if
It's,
they've been technology differences that what these digital things can do now.
the base is
Probably similar.
And what you-
have now is, instead of your dark room, you have
the program
programs out there that
analyze,
an image,
and especially
take a raw
which it's called,
Oh,
analyze an image,
and then change value,
pixels,
and suddenly
mean something
then you didn't.
realize.
yes, that's absolutely fascinating. You know, one of the reasons I enjoy talking with you is that I actually learn more than you learn from me. Because, you know, as I say, Captain Hook, I know, you know, my wife keeps saying, what are you going to do about that telescope? Why don't you open the box? And then she realizes who she's dealing with, and she's, no, keep it.
And then we,
Well, then we getting into the whole, if the sky is darker, I don't know if you know who Bob Fugate
is who's out
Arizona,
and a friend of John Quinn, the astronomer. And I've actually been learning a few things from him. He does imaging. And one of
the things he always, the simplest thing he always said,
the
darker your sky, and this is something you'll hear from visual or imagers,
the darker
your sky, the more signal you get, and the cleaner
the
resulting image without having
you do as much
manipulation.
to it.
You know, there's one other part of this that I would like to, is really interesting. The canals of Mars. Okay. I went to a meeting of the Western Amateur Astronomers in Yosemite in 1954. It was magnificent. I mean, the skies, let me tell you, at 7,000 feet. And one of the people there had a photograph, which he'd gotten from Claude Tombaugh, the man at Lowell Observatory who found Pluto, which he said was the only photograph that showed the Martian canals. Well, it didn't show the Martian canals, but the crucial thing was that when Earl Slifer went to South Africa in the 30s and in the 50s, when Mars was the closest opposition, he took thousands of photographs with a Lamont Hussey telescope corrected for photographic focus. And the length of the exposures was 2 seconds, meaning he didn't see anything. Because in 2 seconds, the atmosphere, you know, they didn't have adaptive optics. And all of a sudden in the 70s and 80s, when we, you know, we had these better emulsions, things like that, and you could, you know, hundredth of a, or 200th of a second, hey, those aren't canals. Those are for Schluggener craters.
Clifford.
Yeah, interesting. Other names, I meant Harlow Heber. Earl Slifer's brother was Vesto. Vesto Melvin Slifer, go figure. Thank you very much for your attention. I've enjoyed, was it 3 years, 4 years ago? 4 years from now, I don't know if I'll be gaga. You can, 4 years from now, I'll be gaga, and then I can give you a really good lecture on aliens, okay?
All right.
You know, from personal experience, you know, that's what, oh, thank you, thank you. Sure. I hope that you will allow me, while you have your business meeting, and it's still light, I hope you will allow me to leave and wend my way home.
Absolutely. We won't be hurt too bad. Thanks again, Rudy.
Sure.
Appreciate it.
Oh, you're most welcome. You're most welcome. Now, how do I guess I go escape.
Leave.
Well, actually, let's just go back to the camera view.
Or just, yeah, stop sharing.
That way I can
Just go
see
back.
people.
Oh, I'm
Yeah.
sorry. Wait a minute. Let's see if there's anything. Well, I can't hear much, but the presentation is outstanding. It is because you can't hear much that you think it's outstanding. I tell you.
We'll, yeah, I've started shooting
Share.
with.
Yeah, that's cool. Then I can go to the grid view and I can see who's officers are out there. So one other thing, Rudy,
Yes.
200.
use another lowbrow hat, t-shirt, or could we get you a restaurant gift card?
You know, I could do with a.
Start with the mid.
hat.
Stop shooting.
We've got two different types. One of them is more
The R6.
standard type, you know, the high like profile. We have another one that's kind of a lower profile and sort of floppy.
I think that's the one that I like.
That one, that is the higher profile.
Yeah.
Yeah,
Yeah, I'd love to have it.
excellent.
Okay.
Sony.
So you in the audience, Doug? There he is.
Well, yeah.
I
will,
do.
I'll send
I'm not sure exactly what you're asking, but those higher profile caps come in two sizes, like a small, medium, and a large, extra large. What size would you need, Rudy?
I told you, I'm a recovering academic, so I have a swelled head.
Okay. It'll be the larger one. And I think I have your address, so. Thanks, Rudy. Thank you.
Okay. Alrighty. So, as far as officer reports, I've just got a couple of things. One of them is we have filled our November opening for a meeting speaker. I'm trying to remember the person's name now, but one of our members that's out in the great state of Montana, Brian Close, actually, pardon? Oh, thought I heard somebody say the name. Anyway, he gave us a tip for somebody at Montana University or Montana State, I forget which, and said that he would be glad to speak to us. So I reached out to that person a couple of days later. He said yes. And so he's going to fill our November date. Being he's in Montana, I'm assuming it's going to be a remote session. And then, as you know, last month we filled July. Thank you very much, Norb. And then in January, I had got Brother Guy to speak to us again. Then that we are wide. I've also some chips over to the Vice President. Sent us a couple of. Somebody else did too. So just a speaker update. We're working on it, and this really is time now to start working on next year. So if anybody, let us know.
Our own Kareem Jaffer, who gives talks for the RASC, I think he's mentioned his interest. We would just have. Now, I don't know if he's on the call, but that's someone we can reach out
Yeah,
to.
I do remember him saying that. Yeah, I don't think we'd ever got a date. You want to try to? Yeah, cool. Thank you. Yeah, appreciate it. Another thing is I mentioned last month that we got a request for an event at Westland Library. And we have been there, I think maybe 2 times before. Actually, a very, very nice venue there. But it is in Westland, so there's a fair amount of light pollution. I remember when we were there before, we were lucky because we had Jupiter and Saturn just perfectly placed for us. And you need something, you know, brighter objects and that kind of light pollution. So I had responded back to the person that contacted us. She was hoping for something this summer. So I said I would look to see, hopefully, what planets might be around, some brighter things in that time frame. But what I'm really finding is that we would really have to wait until mid-August at the earliest. And then we would have a shot at Saturn and maybe Jupiter if we stayed there late enough, and possibly the moon, which is going to rise around the same time. Jupiter and the moon are fairly close, as I recall. So if anybody's got any ideas of some things that you think we could do there realistically, without having planets, which there's a few things, it's just not that many, double stars, things like that. But I'm totally open to ideas. Barring that, I guess I'm gonna have to get back to her and see if something like mid-August works, because it's about the only thing I came up with. So that's the update on that one. Oh, and one other thing, I have still not actually gotten all of our award pins that have been collected the last couple of years to everybody. I'm just going to check my list here to make sure there's nobody here that's owed one that I haven't got one to, and that is not true. I still need to get one to Doug Bach, John Wallbank, and Ani. So just let you know I'm looking for you. But in the meantime, we have gotten 3 new ones. So that's another thing. If and when I find some time, figure out over the last year who really should get these. So it might very well be like AATV people again, because we haven't done much outreach other than that. But I got to put some thought into that, and I might ask for input too, like I did last time, and see what everybody thinks. So more of those. I think that's all I had. So with that, Adrian, you have anything?
Well, just that continuing to do outreach for Warren Astronomical Society, as well as representing Lowbrows for the Explore Scientific Global Star Party. Both myself and Kareem Jaffer, and I'll have to remember to write all this down as I'm saying it. Both myself and Kareem Jaffer have been regulars on that program. And in Kareem's last talk, he mentioned the Lowbrows as well as being a member of RASC. So the name is getting put out there with the Explorer Scientific Global Star Party. So that's, and I've worn lowbrow swag while doing presentations. So that, and the, on a personal note, our trip for Okie, Texas back on, and Jim, I think as you and I know, we'll be planning to head back, and we had a pretty good turnout for Camp Lowbrow, and one of the images that I took with the sign, the tent sign in it, and we'll be heading back there again, and we'll see how many we can get. I know Don, you were there. We've got some time. It's in late September, I think last week of September this time. Last year it was in early October most of the days. So looking forward to that. And then quick note on GLAC. I think trying to remember some of the things we did at our last meeting. I guess Jeff, I'll let you, or John, I'll let you just talk. I know I have some to-dos that I still need to do for the Treasury. So I gotta get some documents to you, John. But the GLAC did go fully on its own. The Warren Astronomical Society, which I'm also the treasurer of that, used to hold the purse strings for GLAC. Well, we made an effort, and GLAC now has its own business account with Comerica Bank, and all of the funds have been transferred to that. So now GLAC is its own 501c3 organization and has its own source of funds. So being the treasurer for both organizations, it was easy for me to broker that transition. And so now GLAC is ready to basically move full steam ahead and doing what we need to do. We will be on site
at Island Lake Rec this year. I think we're still getting some details out. So September 16th and 17th are the dates. And we are going to work on, there will be a table. I know we discussed having a table, and we are going to discuss donations. I would look out for next month for us to have that down and then make an announcement to all the member clubs as far as what donations or what, you know, table space, presentations, start talking about things like that. But yeah, kudos to Pres John Wallbank, who has guided the ship and made sure that we started working on a lot of those. And Sandra Macchia has come back to really kind of guide us in, you know, just a number of different things with the club. Tim Campbell is the VP. Jeff's still doing the secretarial duties, but, you know, has done a great job there. And I can't think of, there's a couple of other, yeah, I think a couple other Lowbrows, Warren Astronomical members. It's basically the Lowbrows and the Ford Club that are basically running it this year. So that's it for my report. And if there's questions, you can direct them all to Jeff.
Adrian, if you're not careful, you're gonna end up like Doug Bach with about 6 or 7 club names behind your name.
Yeah, I see that coming.
Got it.
I got 3. All right.
Because he had a whole bunch of different things after his name. And he said, well, the way it works, the more those you have after your name, the more the jobs.
Yeah.
Anyway.
Yeah, I don't have too much to report. I'm gonna have something in the works. I'll send an email to the officers and we'll take it from there. Okay. Who's next?
Based on the stats here tonight, we had, 36 total, 24 were on Zoom, 12 max in person. The other little bit of news is I've been scouting around for the WordPress hosting because the university's policies, they don't really know if they want to charge it yet, and it's optional. So we kind of, I don't really want to have Krishna's medical school account charged miscellaneously for $500 that, you know, it may be random. So we started scouting around for hosting services, and they start out very reasonably at like $3 or $4 a month, various levels of service for bandwidth and storage. And I got 3 that look reputable that I'm going to try to chart out and present to the officers as soon as possible. And then we'll get started with that. One suggestion that I thought was really good was putting on Amy's new objective lens feature and using that as kind of a pilot project to put stuff online and let people contribute. So that may be a way to go. Nobody's really decided on anything. Committee meeting I've been remiss about holding. So apologies to those who are expecting something.
Okay. Amy.
Hello there. Nope, I don't have anything. What Jeff just mentioned might have been something that I had brought up, but thank you, Jeff. And we're just basically starting that new feature and looking forward to it. So I'll be sending the next reminder out, I think next week for the June issue, and we'll hopefully get some more contributions.
Thanks, Amy. And fresh back from out west, Jim.
I can barely hear you, Charlie. Did you call my name?
I did. Yeah, sorry about that. I kind of let the microphone get away from me.
Okay, well, I got back. And
Yeah,
that's
why I'm
about
just
what I
saying,
have
fresh
to
back
report.
from the West Coast.
Yeah. But no, I don't have anything in the works, and you should go on to the next vice president or other officer.
How about our treasurer, Doug?
just trying to unmute here. So we have 182 gross number, 182 memberships. 14 of those are ones we've been carrying because of COVID things, and so still a high number. $12,938.16 in the treasury. And that's after the last meeting. I renewed our PO box for 182 bucks, made our donation to the Clear Sky Chart for Peach Mountain, $60. And then our usual newsletter printing and mailing, and our AT&T hotline, which I don't think we've used in a while, but we're maintaining it. Oh, and I did send about $45 to Jack Brisbane for observatory expenses. And the only other item is for those of you that are Astronomical League members, renewals are coming up. Dues are going to be due 1st of July. So I'll be soliciting those. Actually, I've been including those in Lowbrow due renewal notices. I've been including that. So expect this weekend, I'll send some general statement to the membership for those that might want to join, and also a reminder to those that are already to renew. It's still only $7.50 for a year. You get the quarterly Reflector magazine. You have the opportunity to join in any of their observing clubs, where you can get certificates for everything from the Messier objects and comets to the Herschels, and it's really geared still, from what I can tell, visual observing and those kinds of things. But it's for $7.50 a year. It's quite a bargain still. So expect solicitation for that, and I think that's everything I have.
I
Go
have
ahead,
one
Jim.
thing. The observing programs are excellent. Those of you who aren't familiar with them should look them up online. It's good to join the Astronomical League to support their activities, but all of the programs are online, and you can just dive right in.
Yeah.
Yeah, it's $7.50, right? The $7.50.
$7.50.
Yeah, because I'm the AL coordinator for the WAS, my renewal will probably come there, but I echo what Doug and Jim are saying. Definitely consider joining the Astronomical League. Fantastic opportunities there, and especially if you're looking to kickstart your visual program, Matthew, or I think they do have, they may have imaging programs now. I need to check the site and find out.
They just might.
Yeah, so that's a great way to start. If you're not sure where you want to start with your astronomical career or get some ideas, that's one way you can start. And it goes from stuff like Messier objects down to Barnard objects and other part. You'll end up knowing the sky really well if you go through a few of those programs. So
some of the programs require either drawings or images. So I think they've been accepting images for things like double stars and other programs for a while.
Yeah.
Okay.
But in my emails, I'll include links to their website and pertinent things that let you get a good feel for what they do and what you can do with them.
Okay, thank you. So Jack Brisbane, our observatory director, sent an email and said he was not going to be able to attend tonight. He did send a little report though, so I just thought I'd read that. And he's saying that the observatory is ready for public open house events, and there has been no new graffiti on the observatory building walls. That's nice. The Michigan Math and Science student, the MMSS group, is scheduled for Monday, August 1st, and a rain date of August 3rd at Peach Mountain. We need to assemble and test the club's 17.5-inch Dob for the MMSS event, Astronomy at the Beach, and there is a Lowbrow group that wants to take the scope to Okie Tex, the star party in October. Next week, I will send out an email to the group that has been working on the club's 17.5-inch to assemble and test the telescope. And that was it, other than clear skies.
Jim, you were just Star Master and you weren't gonna take that 17, or is there someone else taking it?
I think Jack believes that we're taking the 17.5, but unless someone else joins us, I don't think that will happen. I'm purchasing Brian Autumn's 14.5-inch Star Master, so that's what I'll be taking to Oklahoma.
Yeah, smaller.
It's smaller. It's easier for me to deal with by myself, given that I'm not as young as I was last year. So
yeah, I saw the 17-inch was, we had some good views, but it was also a pain to, I could see, I think half was trying to get that thing going.
I can't hear what you're saying, Adrian.
Yeah, I saw the trouble you were having with that 17 last year. I think half the night was spent troubleshooting, and then you'd get a couple hours of actual observation in. So you're looking forward to doing more observing.
Do all right, because unlike a lot of people, I learned the sky before I had digital setting circles. So I can find stuff without them. It's just makes for a more fruitful night if I can use them. And there were, we did spend a couple of nights just wearing ourselves out trying to make the electronics work properly. And I think all by itself, the thing works fine, but out on the observing field trying to make the Wi-Fi work was
I'm pretty sure there were conflicts. I mean, out at Okie-Tex, there's thousands of telescopes and no one changes the name of their Sky-Fi unit.
But there are other things about the telescope that need to be looked at, and I think that's what Jack was getting at, and hopefully we'll be able to do that in the next little while. The big problem is we really need to do it under the stars, because that's the only true test. Last year we did it in Dave Jorgensen's shop, and the thing worked fine. But when we tried to find stuff, even with just the Sky Commander, we had difficulty.
Yeah. But I'm bringing smaller instruments as well. We won't have to take up club time, but Doug Bach will be on his own this year. So hopefully he remembers everything.
Yeah, well, I should note for those of you who haven't heard of Okie-Tex or been there, this is the darkest place to observe that you're likely ever to be able to go to without, climbing into the Andes and sitting in the Atacama Desert. So those of you who could manage a trip the last week of September, I really encourage you to go because the skies are truly dark and the folks are friendly, and it's generally a pretty well-run event.
And as we were talking, I just thought of a solution to that Wi-Fi problem. We just need to devise some electronics that will kill everybody else's Wi-Fi except ours. And I even thought of a name for it, Fi Swatter.
I see.
Okay. It's getting late.
Yeah, that qualifies as a conspiracy, Charlie. It's a felony.
You think so? Yeah. Does anybody have anything else?
Yes, Charlie.
Yes, John.
Yes, the president of the Great Lakes Association of Astronomy Clubs. We have an outstanding group working towards an in-person event on the 16th and 17th of February or of September. We hope to have an in-person event. I want to make some comments here. And I would be at the meeting in person tonight had I not been at an event where there were several people that reported positive tests, positive COVID tests. We apparently had an outbreak. I was at a large event last Friday. And wherever there is a large event, this was a dinner. This was actually the Livingston County Democrats Winans dinner, which we have annually. It was well attended, about 200 people there, and we definitely have an outbreak of COVID. Now, looking at the event tonight, every one of you, and I'm unfortunately have to be pejorative here, but whenever we're indoors, we have to wear masks. If we have any hope of having public events in the future, we are going to have to prevent the public from ourselves. We're going to have to mask. There is no alternative to this. This is the reality. If we're going to have a live event at Astronomy at the beach, everyone is going to have to be masked. We're going to have to be respectful. We're going to have to distance, keep out of each other's faces, and we're going to have to be realistic about where we live now. Our group is very energetic. We are going to solicit a donation from every one of the clubs in the Association of Clubs for $300 to $400. We are well funded. We are well funded for this year, and we hope to have an energetic event. Nevertheless, we are threatened by the pandemic. There is no question about this. And people are going to have to be increasingly mindful of this. I can't emphasize this enough. We are in peril of having all of our group activities squenched by an increasing number of infections. With the numbers are going up in Washtenaw County and in Livingston County and in Oakland County. So let's all be mindful of this. If anyone wants to participate in the Astronomy at the Beach, which is going to be Friday and Saturday, September 16th and 17th, we are encouraging people to be there. We are arranging for facilities for both visual astronomers and astrophotographers. We are, mindful of the power supply needs for astrophotographers. We have some creative ideas going on there, but we all are in peril of the threat of the pandemic, which is current. So I encourage all of you to be mindful of this. And also I encourage you to be thinking about what we can do in terms of outreach. Now, you mentioned the Michigan science and engineering students. There are a number of groups who have contacted me about having outreach events at Peach Mountain. The Sierra Club is one of them. Sierra Club is very enthusiastic about having an event at Peach Mountain. And again, this all depends on safety, the safety of the event. So I encourage you all to become more engaged with issues of safety and more engaged with what we can do with one another socially, so that we can encourage health and we encourage the possibility to get together socially in future. I can't emphasize this enough. The GLAC board we have outstanding people. We are a great organization. I just hope that we can have an event that is not a threat to public health.
I agree with everything you said. I'm skeptical that you can hold a mass event that won't have risks, the risks that you're talking about. And I don't know how to handle the public when you can't tell them to wear a mask, you can't tell them to distance, and you can't tell them to respect those that want to do that stuff. So like I said, I'm skeptical. I support astronomy at the beach and I want it to be successful, but I just don't know how it can happen unless the pandemic subsides.
Jim, I really agree with you on everything there. We can tell people to be observant. We can tell people to wear masks. Again, you don't wear a mask for your own health. You wear a sufficient mask for everyone else's health. And we can distance. We can be observant of these things. It's a matter of being socially aware. This is something that's very important. The Astronomy at the Beach event has been online for 2 years. We don't think this is sustainable. We need to be able to congregate socially in safety. And this is something that we intelligent, informed people have to become more aware of, and we have to make this more present in our mentality about all of our social functions.
I agree. I just need some ideas about how to make that happen. I haven't seen many that I think are successful other than, closing, putting limits on the outreach. For
Jim,
example, putting on programs at Peach Mountain with a couple of dozen seniors in high school that we can control. Putting on member nights on the Hill that we can control. Putting on public open houses we can't control. We can't make people do anything.
Well,
The numbers that I'm seeing really quickly, when left to the own devices, the public tends to mirror what's in this room right now. You end up with about a third of the public voluntarily masking at any said event. Just if you pick a random event, that's just been my observation. There's, even with the mandates being lifted, you still have about a third of the public that are going to willfully mask if asked to do so. Like you're saying, Jim, with that other 2/3 of the public, it can go either way. And then one of the problems that we'll have, and this is something that can be discussed, is the number of people in the general public facing Omicron or son of Omicron, getting through it and telling friends, hey, it's not so bad. That becomes a struggle because you have folks that if you tell to mask, look at you. I haven't run into anyone that says the pandemic's just completely over. But I know, Jim, you've run into folks who have said, don't you know the pandemic's over? Socially, it's a free-for-all. We know that scientifically, it's not expected to get weaker. And I won't comment because I'm not a medical doctor. I've things that I've looked at. We're looking at 2024 before
Adrian,
it's like a common cold. So there are going to be some challenges.
Adrian, we can live with this situation if we are intelligent and observant about it. We can do this. Society can do this. If we observant of health requirements, social requirements, we can live with this. If people get vaccinated, if people mask, we can live with this. There's no question.
I just got done traveling back and forth across the country, and no one said one word to me about the mask that I wore as I went in and out of gas station, party marts and other venues. But almost everyone was not masked. And,
Exactly.
while I didn't get flack, on the other hand, I, the only thing between me and a positive test was the N95 that I wore.
Yes, and Jim, you are protecting other people from yourself. This is what masks do. This is an effort. I am engaged in amateur astronomy largely from the outreach point of view. I enjoy outreach. That's what engaged me with the entire activity. We need to be realistic about this. We can't be subjective about this. The facts are that we have a virulent epidemic that can be controlled through vaccination and public health mediation, such as mask wearing and social distancing. Everyone needs to think of this. This is how we will survive as outreach and as social groups.
Okay, anybody have anything else? Hearing nothing, do I hear a motion to adjourn?
One more thing, John, would you mind being put on the officer email? Because we do discuss this thing among the officers fairly regularly.
Thank you. I appreciate that. Thank you, Jim.
Okay. I think I heard a motion. Anybody support the adjournment? Okay, I just saw support. So with that, I assume nobody's opposed.